Okay, so today in Algebra 2, we're looking at 3.6, theorems about roots of polynomial equations. Our essential question for this section, how are the roots of a polynomial equation related to the coefficients and the degree of the polynomial? After today's lesson, you should be able to use roots of a polynomial equation to find other roots. So let's start out with what's called the rational root theorem. So we're going to let P be a polynomial with an integer coefficient. If the polynomial equation P of x is equal to 0 has any rational roots, then each rational root is of the form P divided by Q, where P is a factor of the constant term, Q is a factor of the leading coefficient. Okay, so this is the important stuff. P divided by Q, this is how we're going to find roots, rational roots. Remember that another word for roots are zeros or x-intercepts or solutions. So we're going to start out, identify the possible rational solutions. Again, possible, okay? List all the possible rational solutions for each equation. So this is where we are going to do P divided by Q. So number one, 4x to the fourth plus 13x cubed minus 124x squared plus 212x minus 8 equals 0. So we want to do P over Q. So P divided by Q. So P, okay, the factors of the constant term. So here my constant term is negative 8. So the factors of 8, everything I can multiply together to get 8. So 1, 2, 4, and 8, because 1 times 8 is 8, 2 times 4 is 8. But I also have positive and negative. So I would say positive negative 1, positive negative 2, positive negative 4, and positive negative 8. Those are all of my factors of my constant. I want to divide all of those numbers by Q, which are the factors of my leading coefficient. My leading coefficient in this problem is 4. So all of the factors of 4, again, all positive and negative. So positive negative 1, positive negative 2, and positive negative 4. Now we want to simplify this. We're not going to leave it like this. We always simplify. So I have to take every number on top divided by every number on the bottom. So if I take every number on top and I divide by positive negative 1, I just get all the numbers on top. So I start out again, positive negative 1, positive negative 2, positive negative 4, positive negative 8. Now I have to take all the numbers on top and divide them by positive and negative 2. So 1 divided by 2, I would have positive negative 1/2. 2 divided by 2 gets me 1, I already have that. 2 divided by 4 gets me 1/2, I already have that. So now I'm going to move to the 4, divide everything, the 4 by all of them on the bottom. 4 divided by 1 gets me 4, I already have that. 4 divided by 2 gets me 2, I already have that. 4 divided by 4 gets me 1, that's taken care of. So now the 8, so 8 divided by 1 is 8, I already have that. 8 divided by 2 is 4, and 8 divided by 4 is 2. Okay. So then everything, let's see, I forgot my very first one, the positive negative 1, I have to divide it by 4. So that gets me positive negative 1/4. So these are all possible rational solutions, okay? I know that this is going to have 4 solutions. These are possible rational ones. So let's do that again, identify the possible rational ones. Number 2, okay? So my constant term is 45, so P divided by Q. So on top, I want to list all of my factors of 45. So I start out positive negative 1, then 3, positive negative 5, positive negative 9, positive negative 15, positive negative 45. All that divided by my factors of my leading coefficient, which in this case is 7. So positive negative 1, positive negative 7. So everything on top divided by 1 gives me everything I have on top. Positive negative 1, positive negative 3, positive negative 5, positive negative 9, positive negative 15, positive negative 45. Now everything on top divided by 7. So positive negative 1/7, positive negative 3/7, positive negative 5/7, positive negative 9/7, positive negative 15/7, and positive and negative 45/7. So now you see this time I have a lot more possible rational solutions or rational zeros. So now let's look at using that rational root theorem. now that we know how to identify them. So use the rational root theorem. Here it tells me a storage company is designing a new storage unit. Based on the dimensions shown, the volume of a container is modeled by the polynomial v of x equals 2x cubed minus 7x squared plus 6x, where x is the width in feet. What are the dimensions of the container in feet if the volume of the unit is 154 cubic feet? Okay, so I want to take the equation that they gave me, 2x cubed. Whoa. 2x cubed minus 7x squared plus 6x, set that equal to the volume that they told me, 154. I'm going to solve that, so I want everything on the same side, so I'm going to move my 154 over. 2x cubed minus 7x squared plus 6x minus 154 equals 0. I'm going to list my possible rational zeros, so my p's and q's. So I need all of my factors of 154. So let's see, I have positive negative 1, positive negative 2, positive negative 7, positive negative 11, 14, 22, 77, and 154, all divided by my factors of my leading coefficient 2, positive negative 1, positive negative 2. So all of my possibles, I have everything on top divided by 1, so that gets me everything on top. Plus or minus 77, plus or minus 154. Everything on top divided by 2, so positive negative 1/2. 2 divided by 2 is just 1, right? 7 divided by 2, so positive negative 7/2. Positive negative 11/2. 14 divided by 2 is 7. I already have that. 22 divided by 2 is 11. So 77 divided by 2, so positive negative 77/2. And then, okay, so those are going to be all of our options right there. So now it says, what are the dimensions of the container in feet? So now we want to actually solve this, okay? So 2x cubed minus 7x squared plus 6x minus 154. This isn't going to... So then in order to solve this, I need to do trial and error. So I know that these are possible ones. I know I can have up to 3 answers, right? So these are possible rational answers. So now it's just a trial and error. Pick one and do synthetic division to see if it works, if it's a 0, okay? Let's think about the numbers that we want to pick, okay? What is x representing? X is representing the width of this storage unit, okay? I can probably eliminate my small numbers and my large numbers, right? Because the width, I'm probably not looking at positive negative 1. I'm probably not looking at positive negative 154. I would probably think that the 77 wouldn't work as well. So I'm thinking maybe let's try something in the middle here. So let's just take positive 7. Let's try positive 7. I'm going to see if positive 7 is a 0. So I'm going to put 7 in my box. Do synthetic division with my coefficients. So I have a 2, a negative 7, a 6, and a negative 154. So I'm going to do synthetic division, and remember that if I get 0 as my remainder, then 7 is a 0. So my 2 comes straight down. 2 times 7 is 14. Negative 7 plus 14 is 7. 7 times 7 is 49. 49 plus 6 is 55. 55 times 7 is 385. So obviously this one does not work, okay? So I needed this number 385 to be a smaller number, so I'm going to go smaller than 7, okay? My next whole number smaller than 7 is 2. I'm thinking, that's pretty small, quite a bit smaller. So let's go over here and try a fraction, right? So I've got 1/2, that's pretty small. 7 halves, okay? 11 halves. 11 halves is just a little bit smaller than my 7. I can try either positive or negative 11 halves. I'm going to go ahead and start out with positive 11 halves. Put it in my box. 2, -7, 6, -154. And bring my 2 straight down. 2 times 11 halves, look at what happens. My fraction goes away, and I'm left with 11. -7 plus 11 gets me 4. 4 times 11 halves, again, my fraction goes away, and I'm left with 22. 22 plus 6 leaves me with 28. 28 times 11 halves, again, my fraction goes away, and I'm left with 154. And looky there, 11 halves works. So I know that x equals 11 halves, or since we're talking about this as dimensions, okay, I can change that to mixed number. So 2 goes in 11, 5, so I've got 5.5 times. So x equals 5.5, okay? I can look now, remember that if these are my new coefficients of 1 degree less, so I'm at 2x squared plus 4x plus 28 equals 0. That would be my new polynomial. If I want to see is 5.5, is that the only one that works, instead of, again, just picking all of these and trying them out, because I know that this problem has 3 answers, but I don't know, are they all real? Are some of them imaginary? Once I have it down to an x squared, I'm going to check my discriminant to see what type of answers this equation would give me, okay? So remember the discriminant, b squared minus 4ac. So let's do that. 4 squared minus 4 times 2 times 28. 4 squared gets me 16. 4 times 2 times 28 gets us minus 224. 16 minus 224, this is a negative number, right? Therefore, if the discriminant is negative, okay, I have only 2 non-real solutions. So out of the 3 total solutions that the problem that we started out with will have, the 5.5 is the only one that's real, right? The other 2 are going to be non-real. So my dimensions, okay, because the problem asked me for the dimensions. So the dimensions, if I look in the picture, right, I have an x, a 2x minus 3, and an x minus 2. My x, I found out that works, is 5.5. So 5.5, and this is feet by, so let's plug 5.5 in. So 2 times 5.5 minus 3. So 2 times 5.5 is 11. 11 minus 3 is 8. Okay. So I have 5.5 feet by 8 feet by, now plug in 5.5 minus 2. So 5.5 minus 2 is 3.5. So let me rewrite this. 5.5 feet by 2.5 feet. So 3.5, I just said. 3.5 feet by 8 feet. Those are the dimensions of the storage unit. Okay. Let's try that again. So let's look at the next problem. A jewelry box measures 2x plus 1 inches long, 2x minus 6 inches wide, and x inches tall. The volume of the box is given by the function v of x equals 4x cubed minus 10x squared minus 6x. What is the height of the box in inches if its volume is 28? So again, I start out, I set this equal to 28. So 4x cubed minus 10x squared minus 6x equals 28. Get everything on the same side. So 4x cubed minus 10x squared minus 6x minus 28 equals 0. Find my P's and Q's, the list of possible ones. So on top, list all of my factors of 28. Okay, so I've got positive -1, positive -2, positive -4, positive -7, positive -14, positive -28. All over my factors of my leading coefficient 4, positive -1, positive -2, positive -4. So all my possibles, let's see, I've got everything on top divided by 1. Everything on top divided by 2. So I've got positive negative 1/2, positive negative 7/2. Okay, and then everything on top divided by 4. So positive negative 1/4, positive negative 7/4. And that is going to be it. Okay, so these are my possibles. And again, I'm looking at what is x representing. Okay, so x represents the height of the box. Okay, so let's go ahead and this is where we're going to start. Again, I probably am not going to start with the low number, the 1, or the high number is the 28, probably not the 14. Okay, so I'm going to go kind of middle of the road, and I'm going to go with a positive 4. And again, x is representing a height here, right? So I'm probably not going to pick a negative because no negatives here. So I'm going to put 4 in my box, my coefficients, 4, negative 10, negative 6, negative 28. See if it works. Again, this is trial and error. So bring my 4 down. 4 times 4 is 16. Negative 10 and 16 is a 6. 6 times 4 is 24. Negative 6 and a 24 is 18. 18 times 4 is 72. So I did not get 0 there. So that doesn't work. I need this number to be smaller. So let's go smaller than 4. So let's look at my fractions. I've got 1/2. That's quite a bit smaller. I got 7/2. That's just a little bit smaller. So let's try 7/2. Okay. So I'm going to put 7/2 in my box. 4, negative 10, negative 6, negative 28. Bring my 4 down. 7/2 times 4. Oh, look, my fraction goes away. I get 14. So then I get 4. 7/2 times 4 leaves me with 14. Negative 6 plus 14 leaves me with 8. 7/2 times 8 leaves me with 28. That one works. I know you guys are like, I can't believe all the fractions are the ones working. You know what's making me happy. So x equals 7/2. Or 7/2 is the same thing as 3.5. Right? So this is what is the height of the box in inches. So my height is 3.5 inches. Right? So the height is 3.5 inches. If I wanted to find the dimensions of the box, right? So I know that I'm at 3.5 inches. I can plug 3.5 in here. So 2 times 3.5 plus 1. So if I do 2 times 3.5, I get 17.5 plus 1. Right? So that would get me, let's say 2 times 3.5 gives me 7. 7 plus 1 gives me 8, so 8 inches. And then times, if I plug it in here, 2 times 3.5 minus 6. So 2 times 3.5 is 7. 7 minus 6 is 1 times 1 inch. So those would be the dimensions of the box if they had asked me for that. Okay. All right, so the last thing that we're going to look at for today is what's called the fundamental theorem of algebra. It tells me that if p of x is a polynomial of degree n greater than or equal to 1, then p of x equals 0 has exactly n solutions in the set of complex numbers. Okay. If p of x has a factor of multiplicity m, count the solution associated with that factor m times. For example, the equation x minus 3 to the 4th power equals 0 has 4 solutions, each of them equal to 3. Okay. Here we're going to find all complex roots. Basically, we're going to find all of the roots. We're going to find all of the real roots, all of the complex, imaginary, everything. We're going to solve it. So number 1, 3x to the 4th plus 4x cubed plus 2x squared minus x minus 2 equals 0. I know I'm going to have 4 solutions, right? So I know here I'm going to have 4 solutions. Right? How do I know where to start? P's and Q's. Right? Because this isn't going to factor. I cannot factor this in any way. So P's and Q's. So my constant term is 2. So positive negative 1, positive negative 2. over my leading coefficient is 3, positive negative 1, positive negative 3. So this is nice. I don't have many options here. I have positive negative 1, positive negative 2, positive negative 1/3, and positive negative 2/3. So those are my options, right? So again, I need to just trial and error, pick one, okay? So this time I don't know that my low one or my high one aren't going to work. So I will start with positive 1. I'm just going to check positive 1 and see if it works. So my coefficients, 3, 4, 2, negative 1, negative 2. And 3 down, so 3, 7, 9. This isn't looking very promising. Nope, didn't work. Okay, so positive 1 did work, so now I'm going to try negative 1. So 3, 4, 2, negative 1, negative 2. Bring my 3 down, so negative 3, 1, negative 1, 1, negative 1, negative 2. Look at that. Yay, so I know one of my answers is x equals negative 1. Okay. Now, where am I at? These are my new coefficients. Okay, so I have a 3x cubed plus x squared plus x minus 2 equals 0. I need to do synthetic division again because I'm at an x cubed. Once I'm at an x squared, I could either factor or quadratic formula, right? But I'm at an x cubed, so I have to keep going. Again, I notice I have the exact same coefficients, the p's and q's, because I have a 2 and a 3. So I know that negative 1 worked, okay? So now I'm going to check like 2 or 1/3 or 2/3. You guys know I like fractions, so let's go with the biggest fraction we have, 2/3. So now I'm going to do 2/3. These are my new coefficients, so 3, 1, 1, negative 2. Bring my 3 down. 3 times 2/3 leaves me with just 2. 2 plus 1 is 3. 3 times 2/3 leaves me with 2. 3, 2. Yay, look at that. That one worked again. So I get x equals negative 1. X equals 2/3. I have 2 of my answers. I only have 2 more to go. So now I have a 3x squared plus 3x plus 3 equals 0. Okay. This is what I want to solve now. I notice I could take a 3 out of that. So if I pull a 3 out, then I have x squared plus x plus 1 equals 0. I see that this is not going to factor as it is, so I have 2 options to solve it. I can either complete the square or I can do quadratic formula. Again, you probably know me well enough to know that I'm going to complete the square here because that's what I prefer. So I'm going to take x squared plus x plus blank equals, I'm going to move that 1 over, negative 1 plus blank. I take the number in front of x and I cut it in half and square it. So 1 cut in half is 1/2, 1/2 squared is 1/4. So I add 1/4 to both sides. Now this factors, x plus 1/2 quantity squared equals negative 1 plus 1/4 is negative 3/4. Take the square root of both sides. So I get x plus 1/2 equals positive and negative. My negative underneath my radical comes out as an I. Square root of 3 on the top, square root of 4 on the bottom is 2. And then I just have to subtract 1/2. So I get x equals negative 1/2 plus or minus I square roots of 3 divided by 2. Notice I have 2 answers here, negative 1/2 plus that, negative 1/2 minus that. So my other answers up here, I have negative 1/2 plus or minus I square roots of 3 over 2. These are my 4 answers. 2 of my answers are real, 2 are complex. Okay? Let's do one more example like that. So number 2, x cubed minus 2x squared plus 5x minus 10 equals 0. P's and q's. So my constant term is 10. So my factors of 10, positive, negative 1, 2, 5, and 10. Over my leading coefficient is a 1, so that's nice. All I have are 1, 2, 5, and 10. Again, trial and error. Let's pick some that we think are going to work. So let's start with positive 1. So 1, negative 2, 5, negative 10. Bring 1 down. 1, 4. That doesn't work. Okay. I could try -1, or I could just keep going up. So let's just try all of our positive numbers first. So I went +1, so now let's go +2. So 1, -2, 5, -10. Bring my 1 down. 1 times 2 is 2, 0, 0, 5. Yay, it works. So I know x equals 2 is one of my answers. I only have 3 answers here because it's an x cubed, so I have 2 more to find. Write down my new equation, x squared plus 0x plus 5 equals 0. I can solve this one just as it is because I don't have an x term. So if I just solve this, get x squared by itself, I get x squared equals -5. Take the square root of both sides, I get x equals positive or negative. The negative comes out as I square root of 5. So 2 and positive negative I square root of 5. Those are my 3 answers. Okay, so that's how we find all of the roots, all real, complex, imaginary, all the solutions. P's and Q's, we do synthetic division until we get a quadratic that we can either solve as it is, quadratic formula, factor, or complete the square. All right, so that's where we're going to stop for today. Tomorrow we will look at the second part of 3.6. So today's homework is going to be the 3.6 worksheet, numbers 20 through 28 and 33 through 35.